These engineers wanted to build a communications satellite using low-budget, off-the-shelf technology. The type of devices that had never before been sent into space.
In the mid-'80s, everyone thought we were crazy to do this. The sort of mainstream industry say, why are you doing this? This is kind of like a toy spacecraft, because most spacecraft use special electronics to work in space.
Most satellites at this time were built to withstand large doses of radiation.
If we think back, the 80s was still the height of the Cold War. So many of our critical satellites were designed essentially to survive nuclear warfare. So they were really robust against radiation damage.
But with the team sending untested commercial technology into space, Craig's mission was a big risk at the time.
It carried some very early experiments in digital communications and digital imaging. In fact, it was a pioneer of these techniques. We were flying state-of-the-art technology, similar to the emerging personal computer technology at the time, devices that essentially have an unknown heritage in space. So part of the activity was to see exactly how do these things respond.
No one on the team knew how this untried technology would react in orbit. But the experiment so intrigued NASA that they agreed to launch the satellite for free. But only under the strict condition that it was ready to launch in just 6 months.
To get any satellite designed and built in this time is absolutely record. We're normally talking about years to design and build a spacecraft, and this was done remarkably quickly by the team.
We have ignition, and we have a liftoff.
When we launched the satellite, we got data back. It's always exciting the first time you hear your spacecraft.
To keep these highly sensitive computer chips running, the team installed software to immediately fix any memory failures.
We had what we call error detection and correction coding systems. So if there were any errors in the computer caused by radiation damage, these would be detected and automatically corrected. What we realized then is that we had a unique resource.
Each error message clearly recorded the exact position of the satellite when the failure occurred.
The chips we were flying turned out to be quite sensitive to this radiation, so we were getting a large number of errors. One thing I did was started to map out where these errors were occurring, and that gave me a view of the errors from the perspective of a map. That really then, in a very concrete way, showed you exactly what was going on. And to my surprise, really, we got an awful lot of errors just off the coast of Brazil in a region of the South Atlantic. This area of the South Atlantic was giving us errors all the time, every day, every time we passed through it.
Although unintentional, Craig had helped to create the most accurate map of the South Atlantic anomaly to date.